Okay, here we go. 5 more questions. Here's the first question. We have two functions. F of x equals the absolute value of x minus 5. G of x equals negative 3x. And they want us to find f of g of 2. And it's pretty straightforward. You can recognize the parentheses. By the way, this might have been expressed as a composite function in this way. F of g of 2. Which is a little more ambiguous, confusing, because you have to decide which one do you do first. But these are the same thing. And what we're going to do is, of course, using order of operations, we're going to do the inner one first. So g of 2. And basically, when you use functions, you simply just plug in the number. For every x, you're going to put a 2 in there. So g of 2 is going to equal negative 3. And instead of an x, we're going to put a 2. And so the answer is negative 6. So that's the inner part, negative 6. And then now we want to find f of negative 6. And then once again, we take negative 6, and for every x value, we put a negative 6. So we get f of negative 6 equals negative 6 minus 5, absolute value, which of course equals the absolute value of negative 11, which is positive 11. So our answer is the last one, 11. Next question we have, the number of lines of symmetry in a square. And this is sort of a geometry or elementary math question. And we want to simply, let's just draw a square roughly. And lines of symmetry basically say, if we draw a line through this thing, we could almost like fold the paper over and have equal points or equal comparison. And therefore it would fold together cleanly. So I'll show you some examples. Let's take a look. One line of symmetry would of course be right down the middle this way, because again, if we took this and folded it over, this side and this side would match cleanly. And then of course, if we were to look at it this way, we would have another one, because it is a square. We're basically sort of bisecting each of these sides. And then what I like to do when I'm trying to find lines of symmetry is just basically go around at like a circle. So if we started here and we continue, we discover that, you know what, we could draw a diagonal right through these points because it's a square. So this bottom triangle would be the same as that top triangle. And we continue around and around, and we see we can draw another one. So right now we have 4 lines of symmetry. And we need to figure out, are there any more? And again, we continue around. What we discover is there are no more. If we were to draw a line through here, we could not fold the paper over that line and get a clean fit between the two sides. So the answer to this is 4. So where does 2x minus 5y equals 20 cross the x-axis? For you algebra students, you'll see that this is the equation of a line. And we're not going to really graph it. I guess we could quickly sketch the graph. It'll help us answer the question, actually. We have our x and y coordinates. And we're going to draw this line. And what we want to figure out is at what point does it cross the x-axis. And actually, to help us graph this, we're going to pick out 2 points. And the first point I want to pick out is the y-intercept, which of course is somewhere here. And that coordinate is going to be 0 something. So if we plug 0 into x, we would have 0 minus 5y equals 20. So that point would be negative 4, which is here. So that's one of the points. And of course, when we find the other point, which I'm going to do, is going to be the x-intercept. That will actually answer our question. So how do we find a point on the x-axis? We simply say that y is going to be 0 and plug it in. So if y is 0, that cancels this whole term out, and we're left with 2x equals 20, and therefore x would equal 10. So our point, 10, 0, lies on this line, which is here. And if we were to graph this line, draw a rough sketch, we would see that it crosses the x-axis at 10. Okay, the fourth question we have might be the trickiest, toughest of the five actually, because it can be a little bit misleading. It's a basic percentage question, which you'll see in elementary school, but you got to be careful. Let's take a look at this. It's a shirt after a 15% discount costs $20. What is the original price? And somebody might quickly look at this and say, well, you know, the shirt's 20 bucks. And 15% of 20 is 0.15 times 20, which is $3. So we add $20 to 3, and we get $23, and we think that's our answer, $23. And it looks so simple, but when you go back and check your answer, you say, well, we have a $23 shirt. 15% of $23, we get out our calculator, and we find out that is 0.15 times 23 is 345. So we take 23 minus 345 and we have ourselves a 1955, and we're like, well, wait a second, the shirt's supposed to be $20. What happened? Well, the problem with this is when you do percentages increasing or decreasing, you always want to start with your original amount. And in this statement here, the shirt's original amount, we don't know. We're looking for the original amount. So what we have to do is rewrite this in a little bit of a different way. So what we're going to do is we're going to say X is the original price, and we need to subtract the discount. And the discount is 15% of the original price, which can be represented as the original price times 15%, which is 0.15, and that's going to equal the final cost, which it says is $20. So we've totally turned this around and put what we're looking for at the beginning rather than at the end. And now we just have to solve this. We can look at this as 1x minus 0.15x equals 20. And 1x minus 0.15x is 0.85x, and that equals 20. And then we divide both sides by 0.85 over 0.85, and for speed we could have used fractions, but I'm just going to use a calculator real quickly. 20 divided by 0.85 equals 2353, which is here. And of course, a quick check, we'll say, look, we have a shirt that's 2353, and we took a 15% of that, so 0.15 times 2353 equals 353, and once we took out that 353, we were left with $20, and we have our solution, 2353. And our fifth question is a fractions question. We have 1/4 plus 1/2 divided by 1/4 minus 1/2. And this is a good exercise in fractions because we get to add them, subtract them, and divide and or multiply them. So let's take the first part. As you know, when you do work with fractions, you want to work with the numerator and denominator separately. So let's take the numerator, 1/4 plus 1/2, and find that. We, of course, want to get a common denominator. So 1/4 and 1/2, common denominator could be, the least common denominator would be 4. So 1/4 plus 2/4 equals 3/4. So that means our numerator is 3/4 up here. Okay, let's now do the denominator. Again, we have 1/4 minus 1/2 minus 1/2, which we'll use common denominators and get 1/4 minus 2/4, which would equal to negative 1/4, 1 minus 2. So that means our new denominator, or our simplified denominator, is negative 1/4. And now we have a fraction that's a little bit simpler to work with. And we're going to divide this top by this bottom, because this is basically 3/4 divided by negative 1/4. And when you divide, you can simply invert and multiply. So we'll do that. 3/4 multiplied. We're going to invert this. It becomes negative 4 over 1. And now we just straight out multiply these across. This is negative 12 over 4, which is equal to negative 3. So our solution is negative 3.